Simplifying exponents, when to use the power rule versus the product rule. First, it's helpful to know a couple of tricks that separate the two. With the power rule, you're looking for an exponent that's outside of parentheses, and then that exponent is going to multiply it to all the exponents inside. With the product rule, you're looking for a base that's the same, that's multiplying, and in that situation, you would add those exponents together. So here are 4 examples where 2 of them are product rule and 2 of them are power rule. Take a second to see if you can identify which ones are which. These 2 are going to be the product rule, and then these 2 are going to be the power rule. Let's focus on this one first. So notice that all of our exponents are inside of the parentheses and not up top. That's a good indicator that you're doing the product rule, not the power rule. For each of these examples, it's helpful to separate your coefficients and all of your different variables. When parentheses are touching like this, it's multiplication, and your coefficients will just multiply like normal. So this just becomes 2 times 3, which simplifies to make 6. Your x's will only combine with x's, and when using the product rule, you'll add the exponents. So this becomes x to the 2 plus 3, which is x to the 5. And for our y's, we'll follow the same rule. So this becomes y to the 4 plus 3, which is y to the 7, and this whole term here is our final answer. Notice real quick how this example is a little bit different because this exponent of 3 is outside of the parentheses. And remember, anytime your exponent is outside parentheses, it's going to distribute and multiply by each of the exponents inside. If your number doesn't have an exponent, there's always an invisible 1. So for our coefficient for our 3, the exponent outside parentheses will multiply to that 1, and it becomes 3 to the 1 times 3, which is 3 to the 3. For your x's, that same 3 on the outside is now going to multiply by the 2, so this becomes x to the 2 times 3, which is x to the 6. And lastly, for our y's, the 3 multiplies into that 4, so we get y to the 4 times 3, which is y to the 12, and this whole expression is our answer for this one. Now I know we said it already, but try to take a second to see which of the previous examples this one is similar to. If you said example 1 with the product rule, you got it. Let's give it a shot. Again, separate your coefficients and all of your variables. Coefficients will multiply like normal, so this becomes 6 times negative 4. Positive times a negative is a negative, so we get negative 24. Next comes combining our a's. Remember about any invisible ones if they're not showing. So our 3 a's combine with the 1 to give us a to the 4, and then for b's we get the 2 plus the 2 to get b to the 4, and we have our invisible 1c with our 4 c's, and 1 plus 4 gives us c to the 5. So this is our full answer. For our last example, we have another case of the product rule. Exponent outside of parentheses means this 4 will distribute and multiply by all the exponents up top. Remember your invisible 1 on the 5 and on the c. So for our 5, we get 1 times 4, which is 5 to the 4. For our a's, we multiply the 4 by that 3, and a to the 3 times 4 gives us 8 to the 12. Continue that same idea for b and c. The 2 times 4 would give us b to the 8, and the 4 times 1 would give us c to the 4, giving us this as our final answer. Thanks for following along. I hope that all made sense and helped clarify how to tell the difference between the product rule and the power rule.